IoT Unplugged, where we talk to industry innovators and major players in the Internet of Things, bringing you the best and latest insights. Tune in to learn more. Today I'm joined by John Weil, Vice President for the Edge Compute and Connectivity Division at US-based fabless semiconductor company Synaptics, to discuss physical AI and IoT systems. So John, welcome. And before we get started, perhaps could you start by telling us a little bit about yourself?
Thank you for having me today. As you said, I'm John Weil. I've been in processors and compute and software systems for nearly 28 years. Worked for a variety of semiconductor companies, but today I run the what we call the Astra product line at Synaptics, which is AI native compute platform that we promote into consumer and industrial, many different markets.
Fantastic. And for those of us who don't know as much, could you tell us a little bit about Synaptics?
Synaptics is a 40 plus year old company, has had several transitionary periods over its life. It's started at early days as a very touch and user interface centric company. We famously known for, trackpads on a lot of people's PCs, and then later on the touch interfaces on cell phones and various iPods. And then over the years switched, from PCs to mobile to now IoT and now more recently AI centric products for all different markets, a multi-market experience.
Great. And today we're going to be talking about physical AI. And this year, everyone seems to be talking about physical AI. So I just want to start with, how do you define it? And how is it different from the generative AI that we've become familiar with, the sort of chat GPTs that we've been using?
Yeah, physical AI is, as I try to explain to people, is a simple way of thinking about moving into the physical world. It's when you take edge AI and then you think about what can you do? Well, you bring things from the cloud down to the edge. That seems natural, but then the next logical step is how do I go from the edge to actual using sensor data and input and output stimulus simultaneously at that edge. So it's one thing to be able to say, have a chatbot in the cloud and then bring that chatbot to the edge. The next thing is, how do I make that chatbot interact with the physical world and make localized decisions as a result of the information it found in that physical world? So
And
physical
why
AI is just bringing it one more step is how I like to explain it.
and why is that happening now? Why has it become such a major focus in the last 12 months?
I think everybody's got a slightly different answer to that. The Synaptics answer is very much the technology's gotten to a point now where we can do something beneficial at that edge. If you had asked me this question 2 years ago, I would have said the technology's not ready. If you had asked me a year ago, I would have said that's very interesting. But today now, what we're able to do, what the researchers in the industry have been able to create in next generation frontier models, and then being able to simplify just the models of a few months ago into something that can run on a more limited compute environment, it allows companies like us and others to be able to bring that technology into devices where it wasn't really plausible before. And so now, your everyday devices can start to interact with you, with the surroundings, and frankly, can make suggestions or inferences at that edge based on that physical data. And that was it was really difficult to do just a year ago, 2 years ago. It wasn't really practical.
And what does that mean for IoT systems? I mean, there's been an awful lot about sort of humanoid robotics, but what does it mean on a practical basis for IoT?
My favorite line is it makes IoT finally work. IoT's been one of these challenging market creation ideas that we've had for, oh gosh, I don't know now, probably nearly 20 years as we started playing with Zigbee technologies and things way, way back and connecting devices. Today, it, no, I guess the original IoT, if you think about it, it was taking data, sending it to the cloud, letting you look at something on your phone, say, yes, open, close, do this, do that, send something back, change the temperature on your thermostat. That's the one that I think the most people in the world understand as an IoT application. Now, what we're able to do is say, okay, sure, there may be a cloud connection. Maybe you still can use your cell phone at a remote location to change the temperature at your home. But now we can make that device, we can take the agentic technologies that we've had in the cloud the last several years, we can bring that down into the thermostat. And now the thermostat can actually make decisions about what maybe you would have decided in advance. So it may have already lowered the temperature, or it may have already started warming it up. It may have already checked the calendar and seen that you're coming home sooner than normal, and it would have made an adjustment to the temperature. Those are all things that, not really science fiction anymore, and it makes the device more intelligent. So the phrase I use is it brings intelligence to IoT. But before, IoT was a data collection concept. Send data, receive data, collect data. Now with the AI capability, it's truly an intelligence factor that we're adding. We're making the device intelligent.
But why can't you do that in the cloud? Why do you have to do it at the edge?
The big one is data privacy. If you don't need to, why would you? If we can do it at the edge now, there's no need to share your whole worldly environment with a data service provider. The second is, and most probably the one people focus on more, because I think we've given up a lot of our data privacy in our industries, is speed and cost. So the more things you send to the cloud, the more the cloud service costs go up. Therefore, they have to charge you reoccurring service fees, a monthly subscription, something. There's somebody monetizing your information somewhere in that value chain. But if we can do it at the edge, there's less monetization requirement, meaning there's not cloud costs, there's not data transfer costs. The latency improves dramatically. Maybe in your home you don't care as much, but in industrial applications you do care. And so you improve latency, you improve privacy, and you fix the monetization.
Just quite interested in that though, because, to work at the edge, you
Mhm.
can only there's only a certain amount of compute. So what
Yeah.
AI workloads can realistically run on devices today, and what ones still need cloud resources?
What we're seeing is I'm going to use home products in the home as a reference because I think your listeners will probably connect with that the fastest. If If you contain the device's knowledge, the intelligence factor of what it needs to know, what it needs to react to, and that can be contained, we can do quite a lot at the edge today. If you're looking to bring the world's knowledge to a device in your home, then that technology is not ready yet today. Even PCs, full desktop computers struggle with that level. You still need the cloud. You still need the cloud if you're trying to cross boundaries. If you're trying to combine information from, say, in your home with information somewhere else, you want to know what the weather is, you want to know other input stimulus from some other area, you use the cloud still for that. But very simply, command and control things, human and voice interface, status information, things like that. It can all be done at the edge quite comfortably today. So we've been partnering, and this is in the public domain, with Google a lot, and Synaptics and the Google relationship, and the research work we've done together. We're able to do things today with some of their Gemma models on devices where you can interact with the device. You can say, make a cup of espresso, and I'd like it extra strong today. And what did I have yesterday? Oh, you had a cappuccino yesterday. Okay, I didn't like yesterday's cappuccino. Can you froth it a little bit more or add more milk? Like that kind of ability to have personal interaction with the device sounds kind of science fiction, but it's actually quite plausible.
And yeah, I suppose that's great for your coffee maker or your fridge to chat to them and get ideas for. I've heard sort of all the things that are in my fridge make me a meal planner for the week. But when I mean, a lot of our listeners will be interested in the sort of industrial applications for this. So where are you seeing the
Sure.
earliest commercial deployments for physical AI?
Well, the big one is robotics, and the industries have been working on robotics now for quite a while. You know, the robots, if you think about like pallet carrying robots and factories, they tended to follow lines, follow instructions. They're wirelessly connected to some data center or cloud somewhere that's giving them instructions on where to go. But with the next gen ones, they're able to do a lot more localized decision making within the confines of that warehouse or that plant, and it can do it a lot faster. And I don't mean the robot has to necessarily move faster, but it cuts down on an amount of things where the robot gets confused and has to wait for the cloud to go, okay, I'm going to shift all these things around. It can make localized and autonomous decision within the confines of that facility. Some other ones we're seeing is in the medical space. There are some things there that I would have said, and I call these kind of light industrial, meaning it's high quality, high reliability devices. But in medical equipment, I think we're going to see some very interesting breakthroughs in the coming years because we can, as a industries, configure these devices now to be able to look at data and infer decisions in a much smaller. I'm trying to think of an example without giving away the customers that are doing these things, but very simply, at home care. Think of it that way. So to be able to have medical equipment at home where the equipment can measure some aspect about you, provide some insight, and then obviously send that information to your doctor for the second opinion. But it allows the collection of that information. The device can look at it and say, "Oh, okay, this is what I see. Can you move the sensor here or move the sensor there? Get some more information for the doctor," right? Instead of having to send a nurse or a practitioner of some kind to your home to collect that information, the machine guides the user and you can interact with that. And I think that's really impressive. It's gonna bring at home care, especially for elderly or people that are disabled or have or may even be rural. They have a lot. They don't have access to immediate healthcare provider.
But they are then holding the machine, or is the machine actually doing the physical moving
Ah.
of the sensor itself?
The ones I've seen right now, you hold the machine, you interact with the machine. The machine tells you kinda like, we've had these, machines that do the defib stuff, right? It tells you where
Yeah,
to put the paddles, right? So that's
yeah.
an emergency product that's highly regulated globally. But there's the next tier below that are diagnostic products that are just collecting information from the user, and so you may be somebody with a heart condition, you may be somebody or carrying a baby or something, right? These things where you need extra, prenatal care or you need heart care or you need something like that. There's equipment that's, I think, going to be coming to the market in the next few years that'll be able to do those things. So it's kind of interesting research. There's articles out there about it, so people can read about it.
Yeah, no, it's fascinating stuff, and I've been to lots of trade shows where I've seen a lot of robots dancing and kicking footballs and doing somersaults. But how close are we to robots that can actually genuinely adapt to changing environments instead of being stuck behind cages? Moving one thing from one place to another and following predefined instructions.
Yeah, I mean, it's a bit speculative. I think we're getting closer year by year. I said earlier, if you'd asked me 2 years ago where we'd be, I wouldn't have predicted it today. My suspicion is you ask me 2 years from now, and I probably would still get it wrong. It it is impressive how fast things are changing. I think it will be interesting to see. Just it's really a human adaptation problem. I think the technology is probably nearly there. It's just will humans accept it?
I guess
And then what is that risk layer? It's like auto driving cars, right? The technology is actually pretty good, but people just don't trust it.
and also, I suppose there's well, the energy, the battery life and trying to have a robot or a car that doesn't just stop in the middle of the street or stop somewhere because it runs out of power. I mean, how do you sort of balance the fact that you need something to be working all the time, but you need it to be, constantly recharging as well? How can you have a big enough battery that you can make it do what you want it to do?
I think all of us know you can never have a big enough battery. This is the dilemma in the world today. Yeah, I mean, it's hard to predict. I really don't know. I mean, when we are seeing massive improvements in compute efficiency. Synaptics alone, we've dramatically lowered the energy footprint on our latest processors and what you can do in that energy footprint. I mean, we can with our latest products that came out in October last year, we can do amazing things in as little as like 1 watt of power and be fully, an agentic system that's interacting and, making decisions and listening to you and responding to you and making a decision as a result of the conversation you just had and doing that in about a 1 watt envelope. That's pretty amazing.
And what is the amazing thing when you're talking about them?
Well, you mean like what is the use
The
case?
Yeah, what's the use case where they're doing this amazing thing?
The ability to talk to it, like the ability to interact with it and ask it about status information. The fun one that I've given a lot of talks on is the dishwasher. We have a running joke about this, but you put this same use case, this product I just talked about in a dishwasher, and no longer does the dishwasher throw Air 22 at me, and I sit there for 20 minutes trying to figure out why it didn't run last night and why my dishes are still dirty this morning. you can literally just ask the device, what's going on? Why did you not run last night? And it's like, well, the filter's dirty. Can you help me with how to clean the filter? Well, there's a little thing down below. You turn it, you lift, you pull, you scrub it out, you stick it back in, and I'll wash the dishes. And I say that kind of cheeky, but it's really that simple. And today, our way of doing that is, I joke, I pull out my phone and I search for the error and I get a Reddit forum and I read about people flaming about it. And then it's like, oh, it's a dirty filter, 20 minutes later. Right. So but in the past to do that, it would have been, much bigger power envelope, much bigger compute envelope. And therefore it wasn't very practical. Today we can do that in a power envelope that easily fits inside a dishwasher.
Wow. But I suppose the question I haven't asked, and I should do, is it safe? What are the cybersecurity challenges? Could someone come in and find out about my dishwasher? Could the Russians come and spy on my dishwasher?
The safety aspect is something that's going to be judged, I think, by all the different industries. It's really up to customers to decide how much command and control they want to give on things. There are examples of putting like boundary conditions and things in, so guardrails, I think is a term you've probably heard in the industry. And so, with all new technologies, there's unforeseen risks, but I would say it's safer than what people want to give it credit for. It's no more complicated in many ways than the fact that you have a software engineer building these things and putting them in your home already. You already had a connected dishwasher. What was plausible there in the past. One of the things I like about it, where I think safety improves, is you don't have to be connected. And so, you could choose from an agentic point of view to only connect occasionally. So now instead of your dishwasher being connected all the time and its threat envelope being quite large, the machine itself says, I only need to connect once or twice a day to get my time or update my homeowner on what I did today. So it connects and unconnects, and then it knows what it's going to do decision wise and come back into it later. So it's kind of fascinating what you can do when you have something that can make decisions, and infer things locally. The part that's security that I think you'll see more research on is how do you secure the models? So that's the new threat envelope everybody's thinking about. And at Synaptics, we spend a bunch of time making sure that there's security at what I call the DNA level of the chip, so that the chip itself is built to be way more secure than products that were built years ago. And how do we protect the models that customers put inside our chips? And the reason you want to protect the model is if you can manipulate the model, then maybe you can make it step outside a guardrail. And that's what people are trying to understand. So we put a lot of work into making sure our AI accelerators and our security blocks on the chip work hand in hand. You can't have one without the other.
And I suppose, they're always going to be evolving and new threats, and you're always
Sure.
going to have continuing, R&D on that kind of thing anyway. So, because the bad guys are going to be developing just as quickly as everyone else.
There's always a new threat. Yeah.
Okay, which industries do you think are going to be transformed first by physical AI?
Oh, that's a good question. Which industries will transform first? I, I'm a general believer that we as humans don't change dramatically, and the big thing is the objects in our homes will typically transition first. You will see new products, new concepts come to market, and they'll be introduced in and around the home, and then people will have debates on whether those products are useful. But you're going to probably see a whole lot of new products in the coming years that are pushing that boundary, testing, testing, testing.
And you think
So I
they'll be
think you will
domestic rather than
I think you'll
industrial?
see you'll see domestic easier than you will industrial. It
Why?
doesn't mean the industrial is not happening. It's just that it'll be quieter. It'll be under the hood. You won't notice it. People will be rolling it out. You'll see more fanfare in the domestic side.
Great. Okay. And I mean, that's fascinating. And I know I've asked you a lot to predict the future, and every time you've found it, you've said that how difficult that is, which is absolutely true. But I'm going to leave you with one last question, asking you to predict the future,
All right.
anyway, which is 5 years from now. What do you think physical AI will look like in factories that isn't possible today?
I this is an interesting one. I believe it or not, I used to work in robotics and factory systems before I was in semiconductors. So I tell this story sometimes that I used to build robots that built light bulbs long, long, long time ago, nearly 30 years ago. And it was a dangerous job. And it's weird that you would say building a light bulb is a dangerous job, but it's a chemical process that has side effects. And so the operators and things that used to do that were the companies that built those light bulbs were looking for robotic systems to take the danger out of the human aspect. But the work to get those robots to do those things was extremely tedious. This is a long time ago. The robots have gotten a lot better today. But I think the big one that we'll see when you look at manufacturing processes, we always talk about drift in manufacturing. We talk about, can robots predict drift? Can they see the drift? Can they interact with the drift? I think that will get exponentially better. We will see automation systems in factories that are no longer just modeling or trying to predict drift of a process. They'll be correcting that process, making adjustments on the fly. The number of, my robot I built 30 years ago had actuators and grippers and things and was controlled by a PLC, right? Today's robots will have cameras, touch sensors. They'll be able to not only detect the device, they'll be able to tell what the surface of the device feels like. They'll be able to predict, slippage. And so your ability to handle things, tell that the surface or the paint quality is not as good. Like it'd be quite amazing what you'll be able to do from, just think of it as dexterity. The robot gripper alone will be 100 times more complex than a gripper we've ever built as an industry before. And there's a bunch of videos on the internet and people playing with these things, and you can go see this stuff for yourselves. But I think all of that research coming together, I think 5 years, you'll see some pretty magical things on what robotic grippers will be able to do to emulate the complexity of the human hand.
Do you think you'll
When
see
I was
cobot?
doing this 30 years ago, it was painful to grab a light bulb. Like, think about, like, not cracking it, not breaking it, not like it was, and every bulb being a little bit different in the density of the crystal, and, like, it was really hard as an engineer to get that right. Today's systems, they can already do that. Tomorrow's systems will actually be able to give you feedback from it.
And do you think they'll be able to work alongside people as cobots rather than on
Oh,
their own?
definitely. Yeah, yeah. Yeah, I don't think we're very far away from that.
Great.
I
Um,
think I ought to be inside of 5 years if I'm being honest, but that's me speculating. I'm not supposed to speculate, but this is the fun side. This is the fun side of what we do as an industry. What you do, what I do, and all is, how these technologies come together. It'd be pretty amazing. I think the next 5 years are gonna be fun.
Sounds like it. And on that note, I think that's been fantastic. Thank you very much, John Weil. Thank you.
IoT Unplugged.